Hey, Constellation community, it's Ben Jorgensen, CEO and co-founder of Constellation Network. It's Tuesday, June 9th, and today is exciting as I'm going to introduce some new layers to Constellation and really how we are articulating ourselves, our vision and our roadmap, and how that plays into business developments and the technology that we're creating today. So I'm excited to share some new developments and how we're articulating. And we started really thinking about what is our ethos, what are our values, and how are we really presenting that. And one of our big slogans and mottos that we really want to stand by, something that we came up with, which is honest data for a connected future. And I want that to really sink in with the community as we are building tools that improve the integrity of data by adding security to data sources. But what does that really mean? And how does that play into our values and the impact that we want to place on the world? And that's where we came up with honest data for a connected future. And that's what we really want to stand by, that you see that as like a powered by Intel badge, that people kind of hold themselves accountable, that you show compliance, that your data is honest and it's part of a future that's connected. So today I'm going to present to you an articulation of the Constellation roadmap and how we articulate ourselves and provide a little more granularity on what we're doing in the space. But most importantly, we're introducing the Hypergraph Transfer Protocol, or HGTP, which is a new standard for securing data transportation. And that's what we're here to do today. So Constellation's network, Hypergraph, is a resilient, decentralized network that is globally distributed and is built to cryptographically secure complex data types, making this the first scalable cybersecurity solution for big data processing. So to date, we have launched the Hypergraph network, where our cryptocurrency DAG is actively traded across thousands of wallets and sees millions of dollars in trade volume every month. That is completely supported on the Hypergraph network. And why that's interesting is that DAG is just the starting point. DAG is a simple data set. A simple data set is alpha, numeric, and dates. Very simple. And we're doing that to date. This is really kind of putting our flag in the ground that we are on par with every other blockchain company out there. But this is just the starting point. This is not the ending point. And so where DAG represents a simple data structure, we're on a path to cryptographically secure complex data sets, such as videos, images, streaming data, multiple rows and columns around data structures, things that are captured by machines and devices around the world. That's not being done on blockchain. And so really what Constellation is a new communication protocol and standard for securing data transportation. So why does this matter now? Well, a lot of you have seen this slide, but the idea here is the existing IT infrastructure and cybersecurity was not meant to secure all the data that's coming on board every day. There's nearly 4 devices being connected and collecting data per person. That's 1.7 megabytes of data every second. The United States Air Force is producing about 2 terabytes of data every 60 seconds. And the global market for AI and artificial intelligence that uses all that data is about 160 billion. That is a lot of devices that are coming on board. And more importantly, if you break down IT infrastructure, you can break it down into really 2 things. The first is that IT infrastructure is not meant to support the volumes of data. And as such, we're seeing gaps and holes that exist in our current digital infrastructure, giving way to giant data breaches across the board. But most importantly, there's been very little emphasis on securing OT, or operational technology, and IT, information technology, and the dual cross-functional capabilities of both. Essentially, to kind of break it down more, what is IT? Well, essentially IT is the real information flow and data created, while OT is the physical processes and the machinery used to carry them out. So the next level IoT attack is going to become in the way of spoofing and corrupting the AI that is integrated with the OT, that's integrated with these machines that are taking all this data and acting autonomously. And so it's incredibly important that we start addressing these new threat vectors and creating data integrity by securing all the data sources. And this is large part what we're doing with the Air Force, is they see a big vision over the next 10 years to provide new digital infrastructure around decentralized networks. So I thought I'd take a moment to capture where we are and where we're going over the next several years. Today, as I mentioned, we've launched a peer-to-peer payment network, the Hypergraph network. And essentially what this is cryptographically securing simple data sets. As I said, the alphanumeric, the dates, cryptographically securing a ledger balance. And we've successfully done that with thousands of wallets and millions of trade volume being supported on KuCoin. And we're seeing peer-to-peer payments that are extremely rapid across Hypergraph. And there's no transaction fees today. This is a remarkable thing, that you can send somebody money that has a market for free. And we're doing this across a scalable network that's never been seen in this decentralized form. And today, our current audience is open source Constellation community. We're seeing development and self-organization around governance, organizations with about 25 individuals on the governance group, writing values, understanding how the network operates, to people building out videos like the brand videos to help guide the direction and fuel the marketing and exposure and education around what Constellation is, all through the Stardust Collective. And we've harnessed new leadership from our community that's come from passion and excitement to do more. And this is an incredible achievement, that it's easy to say this is where we are today, because this is just the starting point. This is not the ending point. We're not trying to figure out what to do next and how this gets adopted like many other blockchains. We already have that roadmap made. In 2021, we're going to focus on securing multiple data sources and securing complex data sources. This is just a simple evolution on top of simple data types, that now we're going to secure complex data types. And the research and funding and momentum, as well as client data, is all being done by the United Air Force. This is a remarkable achievement, because we are working with one of the largest data producers in the world around creating a secure solution for transforming and transporting data and securing data that goes to multiple vendors, across commercial vendors, to other agencies in the Air Force. There's so many players involved in this, that this is on our roadmap. And it fits nicely that we can build this out with one of the largest customers in the world for data. And what we're ultimately building is something what we call programmatic compliance. And compliance is really showing that you're adhering to policy and structure and terms by an organization, a government, or some sort of rules. Well, Constellation's building out the programmatic compliance, the use of digital auditability through Hypergraph around that data. And our model around this will be to provide a transaction fee, which will go to node validators in the network. And this computes into a licensing fee for our end client. And they're synonymous. So our audience to date for this new venture and for what's ahead of us, that's starting now and going into 2021 in mid-July, is that we're working with the Air Force and about 5 other federal agencies, as well as a few of their commercial partners that we're not allowed to say right now. We're also in the early stages of deploying our technology within existing data processing tools, like Splunks and MongoDBs out there. And this is just the starting point. And this experience and this momentum that we have with the Air Force will push us into 2022, where we start to expose our one of our main visions, which is a machine-to-machine payment network. So we go from peer-to-peer payment network and transferring of DAG to a machine-to-machine payment network. That means that machines should be able to autonomously trade currency with each other. But the interesting thing to note in a machine-to-machine network is not that they need to speculate the price of currency like a peer-to-peer network, but instead, a machine doesn't really care about the speculation of that token. What they care about is the data that comes in the tail of that token. So when you think of a machine-to-machine payment network, you have to think about complex data. Another machine wants to know what the temperature is of that sensor what time it was sent, what firmware update, where was it located. Those are multiple variables, multiple rows and columns that a machine needs to receive to have any sort of value attributed to that token. So DAG and the currency really becomes the liaison or the method or the tokenized authorization of data to be decrypted by another machine in the future. And that's why DAG plays such an insanely important role, not only today in building out our own peer-to-peer network that has value, has adoption, but also looking ahead to how do you create a seamless network where machines autonomously communicate, engage, and transfer data between one another. DAG becomes that token that exchanges value alongside the data that has been encrypted. And so really the model doesn't change. We have transaction fees, we have licensing fees. We just want to create a network, a giant mesh network, whereby which machines and devices are trading data to interoperate with one another. And so we see our audience and our customer base start to evolve into autonomous buildings, smart buildings, showing energy compliant or more effective energy utility, that they're adhering to new government policies around that framework of energy sufficiency. This also explores past just working with the Air Force and working with a multitude of federal agencies, because we're establishing that standard for how data is transacted between machines. We're creating that standard for security. And then you start looking at auto manufacturers, the IoT industry, anybody that's got devices that are coming online and trading data and sending data to a data warehouse. And that pushes us full force into 2023, that now you have this machine-to-machine payment network that's operating on a mesh network, and it's creating new insights. It's creating new data as it plugs in with each other, which is creating new insights. And those new insights can be extracted from the ecosystem and used to enrich new AI, new powered learning, new machine learning, and underwrite new risk management with the value of data. And once again, our job here is not to understand the value of data, but let machines calculate the value of data. What is the value of one data set for another? We don't care. What we care about is providing that level of exchange. And the way that we monetize that is through throughput. How important that data is will be decided by a machine deciding when and how it will be used, and thus securing various throughput on the network. So our model still doesn't change, and it becomes consistent that DAG is an essential role for our ecosystem. And our audience actually expands beyond this. And the remarkable thing about this trajectory and roadmap is that you expand out to new use cases. You expand to new customer bases that are used to buying or procuring data at different stages in the life cycle. Financial institutions will use our data set to underwrite new risk profiles and create new financial instruments. Insurance companies can use this to extract data and create a risk profile for an end consumer based on usage-based licensing or usage-based insurance. Smart cities will create a royalty-based business model around how they are compliant. If you enter a city, if your automobile enters a city, is it showing compliance? Is it showing that the data is secure, that it's collecting the right data, and is interoperable with the other devices? And this is going to create a whole new opportunity for us. And those seeds are already being planted today, because these things take a long time to nurture. And we're already working on initiatives with like a smart city, secure smart city, with the National Cyber City Security Center out of Colorado Springs, and many other organizations, to create this model of operators and boots on the ground to deploy a smart city that's not just reliant on hardware, but is reliant on scalable software like Constellation to provide those guardrails and tools and to support the accounting of compliant data. This is a very exciting vision. And it all starts with today, that we have our main network, we have DAG up, we see it exchange between individuals. And this is an exciting time, as this sets the precedent for what is to come over the next 3 years. And what better to build something with than the United States government? April 29th, 2020, we actually received another letter of support from the 618th AOC. And this is remarkable, as this sets the groundwork, along with about 5 other agencies that I'm not able to mention on this call, but have updated their intentions on working with Constellation and what they aim to do with us over the next year. And this is very powerful because they're addressing something that can be used by multiple agencies, as well as their commercial vendors like FedEx, Maersk, American Airlines, that all play a role in the transportation of military and government services. And this was a real honor, as we received a letter of support last year, and this is an updated letter of support that came with a lot of interest from multiple agencies that we've been harnessing over the past several years. So when you think about the United States Air Force, it's kind of hard to think of where this data comes from. Where is it going? How do you get that starting point? And so we thought we'd put together this slide that shows really where Constellation fits in, but what is the data processing industry looking like? So at the very top, you've got you have the raw data creation. You have tools, solutions, ideas that are using massive amounts of data: business analytics, AI, machine learning, autonomous vehicles, security. These are all things that many businesses, including the Air Force, are using. IoT is like a $1 trillion market cap by 2023. But really, these are just market drivers that are driving the creation of more data. And if you go one step below, how do you capture that data? How do you create and set up the data pipelines or the data tools so you can accurately connect that to business analytics? And those are the open source data processing tools. These are Spark, Flink, Kafka, MongoDB. These are all open source tools that allow you to create a big data product. And when you go a step below that, you look at big data technologies and applications. These are actual companies that have created data-rich products. Red Hat provides support and services around Linux. Splunk provides dashboards and analytics for big data using Kafka pipelines. Databricks, Cloudera, both big data management companies. And right there alone is a $50 billion a year market cap across those given companies. This is remarkable. And this is really the early days. Big data has only really been around for about 11 years to date. So when you go one step below, you have the enterprise customers like Air Force, which is a public sector client, but you have enterprise, public sector, Fortune 1000, hedge funds, the automotive sector, all these mass consumers of data and leveraging products of data as well. And so where does Constellation fit in? Constellation is right towards the top. We're an open source solution that would be integrated inside a Kafka instance. And the remarkable thing about Constellation is we are the first company to provide scalable cyber security infrastructure at early in the development workflow. So maybe this gives like some sort of frame of reference that Constellation is actually bridging the cybersecurity industry into open source data processing tools. And what that means is that we're also working with big data technologies to harden or solidify or productize that for their end customers like the United States Air Force. One of the interesting things in this that we're actually working with the US Air Force is that people like Splunk, where the US Transcom, an agency in the government, in the Air Force, is their #4 biggest customer. That's a remarkable thing. That's who Constellation's working with today. So when you take all this, you can actually start to see how the architecture and where Constellation fits in. We're that open source solution. We're working with these data hardening solutions that end customers integrate. And when you look at this from an architecture deployment, on the left-hand side, you have data sources. You've got these Kafka pipelines that are set up. You have a MongoDB instance with Constellation embedded in there. And really, our Constellation is deployed early in the source of data collection. And once that data's collection is made and hardened, it goes into the Constellation Hypergraph network. This is our technology. This is where we're cryptographically securing complex data, and that all the node operators around the globe are validating that data. And our consensus is running on top of it. And our consensus provides a Byzantine fault-tolerant system to provide security around those complex data types. And we topologically order that data so that it can be extracted and pulled into a Splunk or part files, or used for elastic search of and queryable rich databases. And this whole process allows us to create a unique solution that creates a tamper-proof audit trail around data. And this is the value of Constellation, is really right in the middle of us being able to connect data to security to big data processing solutions. But why does all this matter? And I think taking a moment to look at the simple things of what happens to data. How do we lose data integrity? Data integrity is a fully loaded statement. And so I wanted to take a moment to just show what happens to a simple data set. In this example, the rows and columns, that happens to a data set when there is no auditability, when there is no immutable audit trail like a Constellation. So on the left-hand side, you have person 1, and they're sending their data to person 2 and person 3. And so we start questioning what happened to the data set from person 1 as it went to person 3. Did anything change? Who had access to that data? Was the data compromised in any way? What was spoofed or in jeopardy as it was transferred from person 1 to person 2 to person 3, or machine 1 to machine 2, machine 3? And so when you look through this, you have to actually go back to person 3, has to go all the way back to person 1 and look at and see what happened in that process. Does my data match? No, it doesn't. What happened? Well, you start to identify there are threat vectors on person 1 to person 2 to person 3. The value has changed. What happened? Who had access to it? And how do we fix this? You see the process of what it means to do data cleanliness. And data cleaning is a long process. This is a slow and manual process on most bases. And really, there's no programmatic solution to date. So anytime the data leaves the database, our focus and what Constellation's value and solution is to provide auditability around that data, to create an immutable audit trail around the metadata, so that when you look at the metadata, it is as good as the source data. And when you have the metadata and data, you actually provide entanglement. Entanglement is a concept from quantum physics that Wyatt has embraced and incorporated into the Constellation vision and technology, which really says that these two things are exactly the same, so that this metadata could actually recreate the source data. This provides way more value to the source data because you know what happened to it, you know what was done, you know who had, know who implemented some sort of change, or who didn't. And this auditability provides security. It improves the integrity. It improves, our ability to ascertain what was going on. And so really, when you think about what is the impact of this, moving data from A to B to C, well, think about it in a big picture. We'll just take the federal government who we're working with, and how we create dual use and cross-functional capabilities of a standard of data as it goes from planes to soldiers to the IRS collecting data, and you start talking about how those machines are communicating. That they are, by everybody being a part of this network, they create this global situational awareness that validates the entire data that goes in the system. So you have a network that creates security by creating global situational awareness. Is this sensor reading correctly? Can only be determined if another sensor of the same standard is online. And so without that, you really can't create that standard. But the entire network as a whole provides that global situational awareness. And so the key to interoperability is actually creating global situational awareness throughout the entire network. And so what this slide really articulates is that we're collecting data from all different sources. And at the very top right, you have multiple agencies extracting some of that data and using it for their own abilities. So this goes way beyond just working with the other federal agencies that have a use for this data, which we're out there focusing on building multiple levels of security for that data. A certain agency has a level of security clearance for that data, but that agency doesn't. This also extends to other countries, other allies that we have. Some allies need to have certain permissions and access and security clearances for certain data for things to function and work. Our focus is to provide a distributed ledger technology that secures those standards through our network and provides the rails for interoperability to exist and provide multiple levels of security clearance for different stakeholders of that data. And this is a lot of what we're doing. This extends in major industries. You think about smart buildings, you think about smart cities. You can boil it down into creating security compliance standards. Really, these devices, these machines are creating some sort of compliance on how they operate within the network. And this is a lot of what we're starting to look at with secure smart cities. How do we create programmatic compliance by showing that these buildings are energy efficient? When an autonomous vehicle comes into a city, are they showing that they have the right firmware update so they can go down a certain street or be around civilians? And can civilians check in? And all of these systems require DAG to be the mechanism, the tokenized authorization and means of decrypting data so that other machines can analyze and read those systems. So what have you heard today? It's been a lot of stuff. This is really exciting. But today, we kind of set forth that we spent the last 3 years building our main network, Hypergraph, which is built on a directed acyclic graph, a scalable infrastructure that adds security by topologically ordering data. And we've proved that out by launching a peer-to-peer network where people can send DAG for free. We've built an amazing open source community that's building remarkable products and projects simultaneously that are not just around education, but actually tools that we can use to analyze our network and show and the transparency of our network and the value of our network at any given moment. And leadership is coming in the way of the governance of Stardust Collective, and they're showing that they not only understand the vision, but they understand what really can be done from a social impact of our technology and creating programmatic compliance. And really, it just starts with peer-to-peer payments. But you don't really need a DAG for a peer-to-peer payment network. And that's what we want to show. That's the exciting part, is that we don't need DAG for a peer-to-peer payment network. You don't need topologically ordering. You need it for machine-to-machine payment network. You need it to cryptographically secure complex data types. And you need it to create this open tokenized data marketplace that data can be extracted to use for enriching AI and creating smart cities or connected ecosystems of cryptographically secured data types. A smart city is really just an ecosystem or a collection of cryptographically secured data sources. So what we're doing today, we've launched our network. We're in the process of working with the United States Air Force and multiple agencies and their commercial partners to build out solutions that leverage DLT technology to create programmatic compliance, multiple levels of security clearance around certain data, and provide that proof of auditability. Create that immutable audit trail so we can recreate data and provide anti-spoofing mechanisms and address threat vectors, which is going to pave the way for our commercial deployment and working with machine-to-machine payment network, allowing machines to trade currencies, decrypt data, and analyze that data so that it can make real-time decisions. That's what the network's for. That's why we built a scalable platform. And that will create this new world of data. It'll invite datapreneurs to come around. It'll create a software solution around the AI industry that provides more data in a secure and validated way that will create compliance, that will be that badge that everybody sees, that that nearly powered by Intel, that powered by Constellation, honest data, connected future. And that is the remarkable side of Constellation, where we're going. Can't thank you all. As you know, our leadership, Wyatt, our brainchild, has done remarkable things. Benjamin Diggles has built an entire business with the federal government that leads with Wyatt's technology that's been on his mind for several years and has come up with something that very few humans on this planet have been able to even think of. And Matthias Goldman, our COO and co-founder, leading the way on all of our crypto-related activities and creating the models of the future that companies will be able to embrace. It's one of the most amazing teams ever that we have grown together, and we all work in stride. And we come with some of the best advisors I could find in San Francisco that have leaned into building this as one of the most powerful organizations and really just our starting point. I can't thank you all for being a part of this amazing community and building something that this future has yet to see. And it's taken Wyatt on the development of an amazing technology, with Benjamin leading way and introducing blockchain to federal government and commercial sector, and Matthias navigating his experience in the crypto world and financial background to create one of the most amazing companies. And that's why we are here, and we will be the ones to really steal the show and establish and create a standard for the future. Thank you all. Have a great day.